Good morning. In this particular video, we'll be discussing about CAD standards. So we have already gone through a video which explains all the basic concepts regarding the CAD standards. In the previous video, that is overview of CAD standards, we have discussed about the basic concepts regarding various CAD standards. Anyway, we'll again start over. In this particular video, uh, we'll be focusing on PKS. Okay, so these are the various CAD standards we have already seen. This is actually standard for computer graphics. It has been divided into several parts. One is standard for computer graphics. So graphic kernel system it's a standard which is used for computer graphics. Next, standard for exchange of images. We have discussed about OpenGL or Open Graphics Library. And data exchange standards. The various data exchange standards are IGES, STEP, DXF, CALS, etc. Finally, the communication standards. So we have discussed all these. We have just had an overview about all these topics in the previous video. In this particular video, we'll be discussing about graphic kernel system. Okay, before moving on to that, I would like to glimpse about the basic need for CAD data standardization. So the major reason is incompatibility among representations. So if you are going to discuss about various softwares, or if you are going to work in various softwares, what you need is compatibility. For example, if you have to for our purpose in this particular subject, we'll be dealing with CAD and CAM systems and all. So the basic examples, there were a lot of other basic examples we had discussed in the previous video, but in this particular video we will be discussing precisely based on the CAD CAM systems. So what you have done is, we know that for a CAD software package, we'll run a lot of things. Actually, using AutoCAD, we can create a lot of drawings. If you use SolidWorks, you can create 3D models. So after creating these 3D models, what you will do is you will just transfer this particular drawings into some other software. If you are a CAE, computer aided engineer, so what you do is you'll just transfer these images or these drawings to some other softwares in which you could run numerical simulation. Or either if you have just created a part drawing, and if you have to manufacture that particular part, what you will do is you'll just transfer that into a CAM system. So in all these cases, the major thing you need is compatibility. So of course, if you draw a drawing in AutoCAD and if you're just transferring the same into ANSYS, so that drawing might not be compatible with ANSYS. So there arises a compatibility issue. That is, these are two different softwares. We need a particular drawing. We need a drawing in a particular format so that it could be compatible with each other. So if you make a drawing in AutoCAD, you should create that drawing in a particular standard format such that that drawing should also be accessible in ANSYS. So that is a area under concern. So that is the major reason for the standardization. So these are the major reasons I have already discussed: incompatibility among representations, complex CAD CAM systems. That is, the major problem is incompatibility within the CAD CAM softwares and all, shape and non-shape design and manufacturing data. So that is, if you just move on from one software to another, if you just select a particular drawing, it could also have other details such as geometric dimensions and tolerance data. So all these things could be included within a particular drawing. So these data has to be transferred to another software. So such a thing, again, the compatibility issue arises. That again need to integrate and automate design and manufacturing processes to obtain maximum benefits from CAD/CAM system again. So this statement deals with the productivity. That is, if you integrate a drawing as well as simulation, or you integrate modeling as well as manufacturing, so there comes a link. The link between modeling and automation arises there. So that again increases the compatibility, and thereby that could increase the productivity. So that's this one, and that's the precise form of this point. So again, direct translators and neural format, that is, the absence of the presence of incompatibility leads to the formation of formats or standards which could directly convert, or which could directly take upon a drawing, or which could directly take upon a particular data from one software to another software. That is, we need some neutral formats, that is, some formats or which could be accessible within all the softwares. So simple example is okay, I already said I'll be dealing with CAD systems. Again, the most simple example you'll be familiar with is a picture file format. So there are a lot of picture file formats. Again, if you're working on Word files, so there are a lot of formats which support text documents. So PDF is one type of format. Again, Word is another type of format. Text is another type, .txt, that notepad file. So that's again another form. So the most accessible form, or the most suitable form which could be utilized to transfer the data or to transfer the document file from one particular computer to another particular computer is PDF, that is portable document format. PDF is the best example for the neutral format which we could use for transferring the document file from one computer to another computer. So that's an example. So we need certain neutral formats, so that if you're working on AutoCAD software on a particular solid model, or if you're working on SolidWorks or CATIA softwares on a particular solid model, what you need is, you need the same solid model transferred to another software, which may be an analytical one, ANSYS, Abacus, likewise. So if you are doing that, you need a neutral format, so that a single drawing or a single part model or a single assembly could be accessed in both the softwares without any loss of data. So that is the major need, or that's the major goal for standardization. So okay, so we have already discussed about the various CAD standards. One is standard for computer graphics, standard for exchange of images, data exchange standards, and communication standards. So I think you could be able to understand the basic need for CAD data standardization. What I'm going to do is, I'm just going to start the topic for this particular video. So I'm concentrating on the first standard, the first classification, that is standard for computer graphic, or graph and graphic kernel system is a standard which could be utilized as a standard for computer graphics. So we all know what does actually mean by graphics. Graphic means drawing. So these drawings could be made on anything. It could be made on a paper. It could be made on a It could be made on a glass. It could be made on a screen. It could be made on a wall. So all these things, certain images, a group of images or images are referred to graphics. So when you draw the same thing in computer, so it will actually become computer graphics. So it is actually represented as a computer generated imagery, or CGI. So CGI just means the drawings or the images which you are creating with the help of the computer. So again, what is the role of kernel there? What is actually the role of kernel there? Of course, kernel is a system, or is something which acts as an interpreter between one end and the another end. So as I already said, standards are of very much use standards are very much useful since we have to transfer the data or image from one particular format to another particular format. And that is, I already said, if you have to transfer an image or a drawing from one software from AutoCAD to ANSYS, you need a standard for that. So standard is actually something which promote the portability of programs. So, and there comes something known as device independence. So device independence is something which give a rise to what, if you could visualize, or if you could operate a particular, if you could operate on a particular drawing within a single software within AutoCAD, and if you are able to operate the same drawing in ANSYS, that is called device independence. So otherwise, if you are drawing a particular drawing in your laptop, so if you are using your laptop or if you are using your PC, you have drawn a particular drawing, let that be a CAD model of some machine component within you, using the CATIA software which is being used only in your computer. And what you are doing is you are just mailing that, if you're just mailing by means, if you're just mailing that to your friend by means of email, and your friend is able to open the same drawing, and if he could visualize the same drawing in his computer, that is actually known as device independence. So if you're at the same time, if you're drawing, if you're modeling a particular component using AutoCAD which is being installed in your PC, and if you have to transfer the same image to your friend, so if you face any difficulties such that your friend is not able to visualize your drawing, so there actually the independence is actually lost there, so that you have to take your PC with you, and you have to get your PC with your friend, so that you have to explain the drawing made by you to him. So device independence is actually what is meant by, you can transfer the image from one end to another, or from your computer to your friend's computer, so that he will also be able to visualize your drawing. So such a kind of situation is known as device independence. Such a phenomena or such a criteria is known as device independence. Okay, so for that purpose, for the purpose of device independence, we require something known as standards, or we have to go for standardization. So let us come to the point, kernel. So I already said kernel is an interface between two different systems. So it's actually, it will act as an interface between two different systems. So let this be your friend's computer, and let this be your computer. So what you have to do is you have to transfer an image from your computer to your friend's computer. So there will be certain barriers. There will be a lot of barriers, because you are using your computer, you are using some version of a software, some version of AutoCAD. Your friend is using another different computer. If you are using a PC and your friend is using a laptop, so both have a different configuration, different that might have different operating systems. So various various mismatches might be there with you and your friend. Just like this may be a person from this may be a person from Kerala, and this may be a person from Tamil Nadu. So these two persons has to communicate with each other. What could they do? Of course, the person from Tamil Nadu does not know Malayalam, and the person from Kerala doesn't know Tamil. So what you could probably use? They could use a common language. They could use English as a common language, or either, and that if they use English as the common language to communicate, then the language English become the kernel here. At the same time, if it is a Tamil person and if it's a person from Kerala, so in order to have a better understanding, what they could use is, they could use a interpreter or a translator who is able to understand both Malayalam as well as Tamil. Then that intermediate person is known as the kernel. So the same thing is applicable for computers also. It is actually utilized in order to standardize, or in order to transfer image from one particular form, or transfer data or image from one particular form to another particular form. So that is the purpose of kernel. Okay. Next we'll move on to next one. And here, this is actually an explanation for kernel system. We have to transfer data from one particular form, one particular computer to another particular computer. We need an intermediate person or interpreter. So that is actually kernel. And this graphical kernel system, it actually standardize the documents, or standardize the drawing drawn in your computer, and it is available in such a way that it could be transferred from your computer to your friend's computer. So for the purpose of standardization, this graphical kernel system utilizes certain primitives. For example, let us consider that this is a drawing you have been constructed utilizing your AutoCAD, or utilizing your software, any drawing software you have utilized. You made a drawing like this. You have just added certain textures, certain paints, certain outlines, and certain different shapes and all for this particular drawing. So what this kernel does is, it will make these things standardized, such that this line could be read. The line you drew in your computer is now standardized in such a way that your friend's computer could also be able to give the same visualization to your friend. So that is what kernel is doing. You will draw a drawing in your computer, and this kernel could act as a interface between both you and your friend's computer. And to be frank, this is not actually happening in an easier way. What actually happening is, when you draw a line, you could visualize that as a line, but the computer doesn't know what you have done. Whatever the computer knows is some codes. Codes will be based on ASCII, that is American Standard Code for what? Code for Information Interchange. ASCII, American Standard Code for Information Interchange. So these codes will be in some particular standard formats, that is ASCII. So when you draw a line, this line will be this line will be referred as some codes within your computer. When you mark just point here, this particular point will be given to your computer, or in the form of a particular code. That code may be any number. Let that be 1, 2, 3, likewise. If you just put a color on this particular drawing, this color will be this color will be again coded in some number forms. So that is how it is getting standardized. It's not a simple task. It is actually getting standardized only by means of the way that it is being converted to a particular code. So that's what we are going to discuss. So the primary objectives of GKS standard are to provide the complete range of graphical facilities in 2D, including the interactive capabilities, to control all type of graphic devices such as plotters and display devices in a consistent manner. Okay, so these are the major objectives of GKS. So I think these are self-explanatory. So to provide the complete range of graphical facilities in 2D, including the interactive capabilities, that is to provide major drawing facilities, major image creation, image construction facilities, and it is stated that precisely in 2D, and to control all type of graphic devices such as plotters, display devices, etc. in a consistent manner, such that if you draw a particular drawing in your computer, so that the visualization is made on your screen. So if you are just transferring the same image to your friend's computer, same visualization had to be made on his screen or another output device, a plotter, printer, likewise. So the major purpose of GKS, the graphic kernel system, is to provide an interface between the input as well as the output devices within a single system or with multiple systems. So the major layers of GKS or the layer model of GKS is being explained here. So if you just look into it, these are the major layers in GKS. So the basic one is other resources, graphical resources, operating system, and the graphic kernel system, the language independent layer, the application oriented layer, the application program. Of course, we'll start from the bottom. So what are the other resources? So at the starting itself, if you just come to see some word like other, so what's that? Okay, before going into other resources, we'll start with graphical resources. So what does actually mean by graphical resources? So if you just take your computer into consideration, what are the major graphical resources available for your particular computer? One is your RAM, random access memory. Again, the graphic cards which you use for your computer, which you use for your PC. So what does this graphic card and your this RAM helps? So RAM is actually a temporary storage device. It's mainly used for storing temporary files. And the graphics card, what's the purpose which is being served by these things? This RAM and your graphics card. That's actually increasing the bit rate. That is the number of files which is being processed. The number of images which is being processed is getting increased per second. So that the bit rate is actually that's actually denoted the number of files which is being processed within seconds. So that is the reason the graphical resource actually here we will be discussing with image files. So if we have a increased RAM with increased capacity or increased size RAM, 8 GB RAM, some 12 GB RAM likewise. So it provides some increased graphical capabilities. So in order to tackle the situation for the processing of graphic files, what you could do is, if you are utilizing some high-end softwares, if you are a frequent user of CATIA software, if you are a frequent user of Unigraphics in your particular PC, you could go for installing some graphic cards. So what that helps is, that will help in the processing speed, that will reduce the work of RAM of your computer. So that is what this graphical resources do. That will help in processing your files in a faster way. So that these are the graphical resources available in your PC. So what does actually mean by other resources? Okay, now we'll go for other resources. So here, graphical resources are the graphical facilities which will make the processing of your image files in a faster way. Other resources includes the input devices you could utilize for providing the graphics, such as your keyboard. That's an input device. You could use your keyboard for drawing. If you are utilizing AutoCAD for making drawings, you could use your keyboards. You could input commands for making drawing. Otherwise, if you are using Creo or if you are using CATIA, SolidWorks and all, you could use mouse as the input device for creating the drawings. So the other resources, these are the input devices as well as the output devices could also be considered here. What are maybe the output devices you have? So what? GUI, graphical user interface, that is your particular monitor could be considered as a resource. So whatever drawing you make, whatever line you draw, whatever point you make on the particular window, or whatever drawing you make on a particular software, how it is getting visualized to you, that is by means of the monitor, that is by means of the window. Again, another output device, printer could be an output device. that particular drawing you made is now in paper with you. So you could make that in paper. You could make that in black and white by means of a printer. So that's another resource. Okay, so these are the basic resources, and this forms the base of this GKS layer. And next one, operating system. So what does actually mean by operating system? Some of the examples of operating systems are Windows OS. So I think you know this term OS. But you might have this particular OS thing in your phone, in your computer. So this term is very much familiar for you. So what is this operating system? That's actually the platform which is utilized in your computer so that you can bring about a lot of application softwares within it. So this is actually the basic platform uh, which will help to facilitate the graphical user interface. That is, this operating system that will facilitate the direct visualization of the input which you are giving to your computer. So by means of this OS only you will be able to visualize some things. For example, if you are typing a word, if you are typing a letter A, so that letter could be displayed on the monitor. So operating system that deals a lot of things to make this happen. So that is actually a basic platform required for your PC, or required for your computer, required for your mobile phones, of course. So some of the major operating systems, Windows is an operating system, Linux, again Ubuntu, then iOS, and Android. That's a platform mainly utilized for mobile phones. So that is actually the platform which will facilitate the graphical user interface. Again, the next layer is the GKS, the graphic kernel system. As I already said, in this particular layer, what it will do is, if you enter a letter A using your keyboard in your PC, that letter A will be converted into some specific code. So this code is actually dependent upon the language which is utilized by operating system. So these three layers, I would like to explain these three layers in a combined manner. The GKS language independent layer, application oriented layer, and application program. So first I'll just look into application program. So let AutoCAD may be an application program. So let us consider AutoCAD as an application program here. So AutoCAD, let that be an application program. Then what you're going to do is, you're going to draw a particular component. You're just going to draw an image utilizing the software AutoCAD. So what will you actually do? What you will do is, you will pick the particular application program. You will select the application program. You will select the AutoCAD software. You will click and open it. So from where does you select the application program? So you will select this particular application program from the application oriented layer. That is, this particular layer is available in operating system. So this application oriented layer includes various application softwares, various application programs. If your computer may be installed with Windows OS, it may use some Microsoft Word, Microsoft PowerPoint. It may again use Paint. You may again use CATIA. In that particular software you might have Microsoft Excel, and along with that you might also have AutoCAD. So from that particular application oriented layer, what you have to do is, you have to pick the suitable application program in which you have to work. So you will pick this particular application program from the application oriented layer. Now your application program is opened. What you're going to do is, first you're going to make a line drawing. If you're going to make a drawing, a line, if you're just going to draw a line on the AutoCAD software, what you do is, you will give the line command. So this line command is actually given by you by means of your keyboard. That L is given by you using the keyboard. So you can draw that line. Then you are going to annotate. If you are just going to name that line as A, you're going to name the line as A. So again, what you are going to do is you are going to type the letter A using your keyboard. That could now be visualized on the AutoCAD screen. So how is it getting happened? So you're utilizing your output input device keyboard to type the letter L. So that is being transferred to the GKS which is available in your operating system. So that GKS will convert that into specific ASCII code, that is American Standard Code for Information Interchange. This GKS will transfer that line command into some particular code. Then the language independent layer. This layer is again will convert that code into the application program. Then that application program reads the reads the command in its prescribed form, and that could be visualized in a as a line. So language independent layer. So operating systems, it may have different languages such as different platforms are there, C, C++, Java, now Python. So different platforms may be there within the operating system. The operating systems may work on various languages. So here your letter A may be transferred into any of the languages, and GKS what does it do is it will just convert it into ASCII code, and this ASCII code will be visualized on the application program. So these are the basic layers which you could visualize within GKS. So first in the these are the resources, the graphical as well as the other resources, input devices, output devices, that could be other resources, graphical RAM as well as your graphics card, operating system, that's intermediate platform, GKS that forms as an interpreter between your input device as well as the output window. So this application program you're picking is available in the application oriented layer. This GKS will convert whatever input you give, GKS will convert that into ASCII, that is ASCII codes, that is American Standard Code for Information Interchange. Please keep that in mind. So this code, this might be actually in the form of some numbers and all. We'll discuss it. In the following slides, we'll discuss that. ASCII, this codes may be in the form of some numbers, and these numbers are actually again transferred to your application program such that your application program could display the line, display the command L which is given by you as a line. Again, the command text, the annotation A which is given by you as a text. So these are the major functions which is actually happening within the OS, and that is OS as well as the program application software with the help of GKS, the graphic kernel system. So some of the major primitives which is available in GKS are polymarker, polyline fill area, and GKS cell array. So these are some of the output primitives which is being available. So graphic primitives or some of the output primitives. So we'll just look onto it. First output primitive is GKS polymarker. So what you're going to do is, if you're just going to make a drawing, first what you could do is you could just fix the various points. So in order to fix various points, what you could do is you could you'll give some commands such that a point and all. So what you could do is you could select various types of points. That point may be a circle, that point may be in the form of a cross mark, the point may be again a plus sign, a smaller circle, again asterisk, again a circle with hatching, it's a dot. So different types of markers are available. So what actually happens is, in AutoCAD, that different markers will be available in the AutoCAD software. So you could select that particular marker using your you'll just slide over your mouse. You could select a particular marker which is available within the AutoCAD. So how does the computer know this? How does the GKS help in identifying this? So whatever marker you select, for example, if you select a circle marker, this circle marker might have a code. The circle marker might have a code. Let that be some 100 or something. So what exactly happens is, it's not exactly 100, but just assume that the command you are giving is you need a marker. That mark is actually a circle. So let the code for the circle marker be 100. So what actually happens is, when you select circle marker using your mouse, GKS will convert that into a specific ASCII code, and if that code is 100, what actually happens is that code will be transferred to your application program by means of the language independent layer. And your application program, what it does is, it will display that code as a circular marker. So that is what actually happening within the software. So if these things, if these things are actually going to happen, it could only happen if the GKS primitives are available. For example, if these are the available primitives within the GKS. Rather than this, if you're just going to select some star-like marker, actually it's not available within the GKS primitive. So what could be the message? So you could receive an error message such that such kind of a marker is not available within the GKS primitive. So these are the available GKS primitives. What you could do is you could just select from these primitives. So that is another case. So if you're whatever you do, whatever you're going to do, that things should be available within the primitives. So next one is GKS polyline. So you know what is actually mean by polyline? That's actually utilized for drawing continuous line segments. So here this type of image that could be drawn using polyline, and these are the various types of lines which is available. Polyline is a graphic GKS primitive, and different types of polyline which is available within the primitives are this is actually a center line type 1, a dotted line. So here the width is 5, here the width is 7, and a type 2, here the width is 3. So it's again another dotted line. It's a type 1, it's a solid line. So these are the various type of lines or type of polylines which is being available within the primitives. So what you could do is you could select the suitable one from this. These are the major options you have. Okay, so you could draw an image by selecting any of the line type which is being available within the GKS primitive. Third one is GKS fill area. So we have already made a drawing as just a drawing of a duck. You could visualize that. So in this particular drawing, next step is you have made the outline. Next step is you are going to just fill the area. You are just going to fill this area. So these are some of the type of fill area, the area fills which is being available within the GKS primitive. Here you could visualize a blue color fill. Here you could visualize another texture, a green color texture with a diamond cutout at the center. Again, another hatching, a star type hatching, another type of hatching. Here different type of hatching, different type of textures are available as the fill area primitives. So you could utilize any of this using your command. Again, next one is GKS text. So text is actually characterized by the letter you're going to enter. So if you're going to enter a letter, so it will be in the form of a string, character string. So this is actually represented by means of its the height of the character, the position. So this left, center and the right, that determines the position, the top and the half region and the base and the cap. So all these things will represent the position and the orientation of this particular letter. And another major details are the font of the text. The font of the text is actually determined by the character height. Again, the character expansion factor, the width of this may be the width of the letter. Then additional white space, of course, that is actually what space you require, what additional space you require in order to specify your particular annotation, or what space you might require in order to specify your letter, specify your text, the color of the text. The color, here it is actually black, this is the color of the text. So that's another characteristic, the height of the text, the angle in which this particular text has to be placed. So here it is actually placed in a straighter way. So if you have to incline it, so based on what angle it has to be inclined, based on what angle and what axis it has to be inclined, alignment of the text. So these are the basic conditions which we have to identify before making a text. Next is GKS cell array. So if you just look into this image, you could visualize an array like thing, an array which is made up of black as well as white squares, so just like a chessboard. So this utilize this particular command, this particular primitive enables rasterization of the image. I think you might have been familiar about rasterization. In the first unit itself, you might have studied about rasterization and all. What DDA algorithm, you might have studied about rasterization. That is, you're just dividing an image into small parts such that you are just rasterizing it. You are increasing the pixels. So this GKS cell array could be used for the purpose of rasterization of images which is being available within your computer, or which you are going to draw within your computer. So this particular primitive could be utilized to utilized to fix the pixels of the image. So the final one is GKS 3D. So GKS 3D is similar to GKS 2D commands we have just gone through. We have just gone through the GKS primitives, and GKS 3D is just an extension of the 2D primitives we have already seen, just like the circle. So if you just extrude a circle, it will become a cylinder. Again, if you just revolve a circle, it will become a sphere. Then if you just extrude a square, it will become a cube or a cuboid. Then if you just loft a circle with respect to a point, you could obtain a cone. So it's actually the primitives here utilized are just the extension of what you have seen in the 2D primitives. So here these images, these figures will actually be constructed by means of a group of lines, group of points and all. In addition to that, GKS 3D helps in providing the appearance, helps in controlling the appearance of your particular drawing. For example, a 3D model, a 3D drawing, of course, will include different characteristic features. A 3D model, it could include a wireframe model, or something with the outlines. I think you know what is actually mean by wireframe model. So here the GKS primitive that could include a wireframe model. Again, this 3D model that could again include some surfaces. So the major appearance of this surface will be controlled by the GKS here. GKS helps in providing a good appearance for this particular images. So various shading methods, various coloring methods you could utilize. That is actually mean by rendering. So for that purpose, GKS extra primitives could be available in the GKS for providing good appearances such as coloring, shading, proper rendering, and all. Likewise, again shadowing. So all these things that you might have studied in the algorithms in the in the second unit, these things could be there. So GKS primitives could include these features such that a 3D drawing or a 3D figure could be made in a good appearance. Okay, that's all about GKS. So once again we have discussed about the graphic kernel system, and in this particular video I'm going to conclude here with GKS. Again, in GKS we have discussed about what is actually mean by GKS. We have discussed about the primary objectives. We have discussed about the layers of GKS. It's a very important thing while writing your answer in the exam, the university exam and all. It's a very important thing. You have to draw this. Again, you could explain various primitives which is available within the GKS. Okay, and that's all. Thank you.